Today we will be going over mole calculations, and our first question is how many grams of hydrogen are in a sample of water that contain 223 atoms of O, which is oxygen. Okay, so first, what I like to do when starting these problems is I like to identify what it is that we're looking for. And right now we're looking for how many grams of hydrogen are in a sample of water that contains 223 atoms of oxygen. So this is what we have, this is what we know, and this is what we start off with. And this is basically what we need. But before anything, we need to use the periodic table as a reference. So if you could go ahead and just place a periodic table in front of you so that we can later on use it as a reference as to where I get certain grams and certain measurements of such that relate to elements that we have in this problem. Since we know that we have 223 atoms of O, we know that we need to cancel atoms with atoms. And we know that there are 6.022 times 10 to the 23rd atoms of O and 1 mole of O. And I'll just continue over here on this left side since I don't have room. But then we continue on to 2 moles of hydrogen over 1 mole of O. And our mole-to-mole ratio is 2/1 because we have to remember that H2O is the chemical formula for water. And we're looking at a sample of water that has 223 atoms of oxygen. Here we're able to see that this 2 comes from H2O. And since there's only 1 O, we have 1 mole of O here. So continuing on to this equation, once we've done the mole-to-mole ratio, we know that 1 mole of hydrogen is equal to 1.008 grams of hydrogen. In the previous page, we left off with 1 mole of hydrogen being equal to 1.008 grams of hydrogen. And I got this number by looking at the periodic table. Okay, so this is when you would pull out your periodic table that you have placed in front of you. If we look at group 1, we're able to see hydrogen. And that's if you're looking vertically under IA. And we find that hydrogen is the first element at the very top, right next to the number 1 that labels periods. And we see that the number 0.0079 is under H. And when I round this to have 4 significant figures, this is where I get the number the number 1.008 grams for H. When I input the numbers that we have in our calculations, the result is 4.654 times 10 to the 23rd. Negative. Since originally we have the 23rd at the bottom, but when we brought it to the top, our sign has to change to -23. One of our last steps is to put our answer into scientific notation. And if you notice here, in scientific notation, you only have 1 number to the left of a decimal point. However, here we have 2. We have 7 and 4. So what we have to do is move the decimal point over once to your left. So this turns into 7.465. Then it'll be times 10. However, it will no longer be to the negative 23rd since you moved it over once to the left, which is positive change. So you subtract those and you get 22. And your answer is approximately 7.465 times 10 to the 22nd, negative 22nd grams of H. The reason why I have 4 significant figures in my answer is because our smallest number of significant figures is the atomic mass of hydrogen, which again is 1.008, which is 4 sig figs, just like the 4 sigs we see here.